As Sir said, my name is Sharath Kumar D. I'm currently working as Technical Associate in Forest Survey of India, Dehradun. So today's session is going to be about basics of remote sensing and its basic applications in ocean science. So let's get started. Hope my slides are rolling. This is the basic outline about the what we're going to discuss about in this particular presentation. So we'll just cover the basics for now. So yeah, what's remote sensing? We'll just have a general outline about it. Remote sensing is basically the art science of figuring out what's happening on the earth, whether it is on land or in ocean or up in the atmosphere, without actually touching it. Instead of physically being there, we can use this tool and technology to gather information from a distance. So, believe it or not, humans are really using the remote sensing on everyday basis. When you look at something, hear a sound, or smell something in the air, you are sensing your surrounding without making direct contact. Actually, so that is also called a kind of remote sensing in action. So actually, we in that position we are collecting different sorts of informations like sound waves, gravitational force, uh, for distance measuring, and light and energy, like how our eyes detects lights and how the satellite uses infrared sensors. Actually, we are using infrared sensors and infrared light in our TV remotes and fan remotes, etc. So why does matter actually? So once we gather this data using different sensors, we can analyze it to learn more about the world, like tracking weather patterns, mapping terrains, or monitoring the environmental changes, etc. Um, so here is the remote sensing credibility and capacity. Remote sensing let us observe vast area of Earth with incredible details and frequency. It also plays a vital role in disaster response, helping with early warnings for tsunami, cyclone, and accessing damage after the any coastal hazards, and analyzing the environmental impact. Beyond that, remote sensing supports safe maritime navigation and help plan for sustainable fishing practices as well. Uh, so this slides actually explains basic types of remote sensing. One is audio based, second one is geophysically based, and third one is spectral remote sensing. So it is very important for our ocean studies. So spectral remote sensing involves capturing light reflected from surface using cameras and filters. So let's just have the example of two different cases. Case one, a regular camera with black and white or color film capture the light across the visible spectrum. Case two, camera with multiple lens and filters like blue, green, and red captures specific wavelength. So this is called multispectral remote sensing and helps us analyzing uh, different earth features like vegetation, water bodies, or urban areas, etc. So understanding electromagnetic radiation is very important for the basic of remote sensing. Electromagnetic radiation is a type of energy that moves through the space as waves created by interaction between electric and magnetic fields. It travels at the speed of light and comes in many forms like visible light, ultraviolet radiations, infrared, radio, and even in X-rays. So how it can be measured? We actually describe this energy into two ways. One is by frequency and another one is by wavelength. We all know what is frequency and wavelength. Frequency is how fast the wave vibrates, whereas wavelength is the distance between two different wave peaks, consecutive wave peaks. And there is a simple formula to calculate the energy of EMR. that is E is equal to hc by hcf or hc by lambda. E is energy, h is Planck constant, c is the speed of light, f is frequency, and lambda is wavelength, where it is usually measured in millimeters. So the EMR spectrum, if you plot all different types of EMR based on their wavelength, you get the EMR spectrum. So it ranges from very high energy, that is gamma rays, to very low energy, that is radio waves. The part we can see with our naked eye, that is visible light, it's just a small, very tiny slice of that EMR spectrum from violet to red. Why it is matters in remote sensing? It's a very interesting thing. In remote sensing, we use EMR to study objects from distance, right? So by measuring the radiation that is reflected or emitted by a surface like land, water, or any other Earth surface, Earth features, we can figure out what is it and what condition is it in. So it is like reading the Earth signals without even touching it. So hope you all got the basic idea about remote sensing. Now we will get into the platforms and sensors. So remote sensing usually works by using the energy, and the process involves like different key steps, as I already as I shown in the last figure. So here a device that is used to detect the reflected or emitted EMR from an object is called sensor, and the vehicle used to carry the sensor is called platforms. There are different kinds of it, so let's just quickly go through what is it. Remote sensing platforms are the vehicles that carries the sensors to collect the data. So it is of three types. One is ground based, example towers and tripods. Second one is aerial, that is drones, aircrafts, etc. And third one is satellite, orbital satellite. So satellite remote sensing will give you the holistic and synoptic view of the Earth features. So it is very useful for oceanographic studies. Now here comes the airborne platforms. So airborne platforms are the remote sensing vehicles that flies in atmosphere. So it includes man aircrafts like planes, helicopters for large area, high quality imaging. And second one is unmanned aerial vehicles, that is UAV, or we can also call it as drones, for low altitude, high resolution data. And it is very much useful for remote areas like in Himalayan ranges. Some places are very remote and we can't enter into it, or in some parts of Western Ghats, some jungles are it is very remote. We can't enter there, so we can equip the UAVs or drones for surveying that particular landforms. So here comes the ground-borne platforms. So these have two different types. One is LIDAR, that is ground-based laser scanning. So it uses the laser pulses to create the accurate 3D models. The next one is terrestrial photogrammetry. This uses the ground photos to map land features for surveying and research. Um, So it is third type of platform is spaceborne platform. Spaceborne platforms are the satellite used in remote sensing to collect the data from the space. So they help monitoring Earth's atmosphere, land, and ocean on a global scale. It is very in a large aerial coverage. It is actually call it as um, small scale mapping, where the area is very large and the details are very coarse in terms of scale of the mapping. So these platforms are vital for weather forecasting, climate studies, disaster management, and national security. There are two types actually in this. First one is low Earth orbit. So this satellite below 2,000-kilometer altitude. So it uses the high resolution imaging and tracking changes like wildfires, forest fires, and weather patterns, etc. Second one is geostationary orbit. So it is all of about the satellites at approximately 3,000 to 36,000 kilometers altitude. It provides the continuous global coverage ideal for weather and climate monitoring. So it is the CWIP's satellite view. It is a daily. It This particular slide tells about the daily challenges in remote sensing. CWIPs capture the Earth surface in visible spectrum only. So the scanning pattern creates the gap at low latitude, that is near the equator. You can see that cut through the in the center of the globe, and the cloud cover is over 50% of the ocean aerial coverage, and blocking all the visible and infrared radiation, because visible and infrared radiation cannot be got penetrated into the clouds. So the solution is microwave, but there is no such scope for it, because only now the technology has been evolved. So this limits the satellite visibility and affects the data accuracy in ocean monitoring. So this is the big challenge for us. So it is here comes the active and passive sensor. So there are two types of sensors we have. So let's discuss about the problem of choosing between these two sensors and what is it actually about. So here is the active sensors. Active sensors actually sends out their own energy, like microwaves, radio waves, or laser beam towards the target and measures the reflected signal. They have their own source of energy. That is the main thing. And they work well in all weather and lighting condition, irrespective of any weather condition. It works well. Example, we have radar, which detects the object and their positions using radio waves. Then we have lidar, that uses the laser beams to create the 3D maps, and then we have sonar that uses the sound waves. So these sensors are ideally used for quick data collection and very remote areas. Then we have passive sensors. So it doesn't have any own energy producers. So it considers the sunlight as the energy source for its reflectance capture. So example, we have cameras. Cameras, we don't have any own energy production, means incident light production. We use the sunlight for the light sources. And we have infrared sensor that is also doesn't have own energy source, which helps to detect the heat energy. Also, we have multispectral sensors which used to capture the image in uh, multispectral, like multiple light bands. So these sensors are ideally used for the targets emits enough natural energy, and it is very easily visible on the naked eye. So here is the comparative table between active and passive sensors, and why it is actually used, and the advantages and disadvantages of over each other. Mm, so here it is the components where we can see of active radar and passive SST remote sensing methodology. Here, active sensors, it is ideally used for radar altimeter, sense signals, and measure the reflectance. And passive sensors, like SST monitoring, we have like it only receives the naturally emitted energy. We have examples like MODIS, AVHRR. So these are all the important examples of passive sensors. So why satellites? So oceans are very vast. We all know that we couldn't able to equip that much of manpower, that much of energy, that much of ships or cruises to go for in situ observation. So for a regional plot or the global coverage, satellites are the best options. We can have the advantages of economical possibility, and risk is also very less. And we can measure the wind forcing and response through satellites. So these are all the main advantages why we should choose satellite for large global coverage of oceanographic studies. So here we can see that in the left-hand image, we can see that ship surveys take 1 to 2 weeks to cover a particular area, shown by the blue tracks. Ocean condition actually, it changes rapidly. SST patterns will shift just in between 4 days, and the two different maps shows that. So whiter shades is the actual cold water areas, showing the dynamic currents and upwelling zones. So this particular plot itself highlights the advantage of satellite remote sensing for fast, wide range aerial coverage of ocean monitoring compared to the slow ship-based methods. So here is it is the imaginary hypothetical image of alternative of the satellite oceanographic surveys. It is practically and economically impossible. So let's get into the motion color remote sensing. So for you guys, I think most of you are from marine background or oceanography background. So for you guys, at least, like it's not just water body. It is like invisible forest. At least it's in my terminology. So with remote sensing, uh, four important parameters can be found in seawater. One is pure water molecule, that is H2O. Another one is pigments in algae, like chlorophyll A pigments. Small particles like sediment, like SPM, that is suspended particulate matter. And colored dissolved materials like CDOM. CDOM is nothing but chromophoric dissolved organic matter. And in few cases, we have bathymetry as well. So first three parameters are considered as water quality parameters, which really indicates the real condition of that water body, whether it is apt for or reliable for any particular land, living things to exist or thrive on that particular condition in that water body. And bathymetry is nothing but the topography of the seabed. So this slide actually explains the radiance component in ocean remote sensing. So LT is nothing but total radiance. It's the energy detected by the sensor over water body. So it includes water leaving radiance, that is denoted as LW, energy from within the water body, and LVB is the subsurface volumetric radiance that is reflected from uh, particulate matters and plant tanks, etc. And LB is the reflectance from the bottom of the seabed, like it is the seabed's reflectance. So LS is denoted for surface reflectance, where the sun glints from the water surface. So these components helps in analyzing the water quality, depth, and underwater features of any water body. Not only just for sea, it can be applicable for lake ecosystem and marine water lagoons, etc. So ocean color remote sensing needs accurate atmospheric correction because it includes various level of in so much of calibration techniques, that is pre-processing of a particular satellite data is very much needed for any kind of analysis. And the sensor calibration, it is very needed because about 90% of the signal comes from the atmosphere and surface. Even 0.5% error can cause 5% of mistake of ocean data. So you can see the proportion. Even 0.5% of mistake can cause 5% of mistake in the ocean data. So it has to be very high precise, like nearly 0.1% precision needed for a reliable result. Yeah. So this plot shows different substance in water reflectance light differently. Like we can see the sediment have shows the high reflectance, especially in NIR region. Water shows the lowest reflectance, and CDOM and chlorophyll shows the moderate reflectance, which each have the unique pattern as well across the wavelength. And this helps in identifying the water quality using remote sensing. So this is the spectral signature. We used to call it as a spectral library, where the spectral RRS remote sensing reflectance has to be under this particular range of wavelength only to determine whether it is sediment, water, CDOM, or chlorophyll, etc. And here comes the chlorophyll. So you guys know about chlorophyll, right? So how remote sensing is going to be useful for identifying that ocean chlorophyll. So remote sensing sensors like MODIS, CWIPS, um, and VIRS. Scientists like these are all the major sensors that can be used for chlorophyll concentration identification on any ocean level. Um, Chlorophyll concentration actually serves the proxy for the phytoplankton biomass, making it as a key indicator for ecosystem health and nutrition dynamics. Remote sensing enables the consistency and large scale observation of these patterns, which can be used for climate research, fishery management, and marine conservation efforts, etc. Uh, Mostly, chlorophyll will be identified by the passive sensors, where it measures the light scattered and transmitted upwards from the ocean surface. I mean, its color of the ocean surface, and it will be carefully distinguished between transmission and reflect. So, the problem actually is about most of the signals, about 90% of the signals at the satellite is not ocean color, it is the just interference from the atmosphere. Because the reason why the sky is blue, reason why we can see the sky turning into orangish red in evening, it's all in the atmospheric interference. So satellite is in atmosphere, so obviously the light will go through so much of layers of interference, so we cannot assure that it is the actual ocean color of that we are seeing from the satellite. So sunlight that has scattered or reflected by the molecules or aerosols in the atmosphere, it is called atmospheric interference. So this is the satellite's field of view, where we cannot actually assure whether it is a proper ocean color. So for that, it needs proper atmospheric correction. So here is the component of passive ocean color remote sensing using the visible wavelength. Of course, it will have whether if it is not using the microwave remote sensing, it will have the cloud color cover interference and atmospheric interference. And here comes the sea surface temperature. Sea surface temperature, it measures the infrared radiation basically emitted by the ocean surface. It is less radiant, and on insensitive data, like it is very less reliable because it will change in every hour. We cannot go or place a particular device to measure on the daily basis or hourly basis. So satellite remote sensing is the only go to a reliable technique for assessing the sea surface temperature. The primary data source will be polar orbiting satellite missions like NOVA, which is sensitive to the atmospheric effect and cloud cover. And the applications you will know, like El Nino, La Nina, global warming, sea level rise in fisheries, water quality, harmful algal blooms. We can use this sea surface temperature anywhere and everywhere around the ocean straits. And the main limitation is that no direct conversion between the sea surface temperature and sea surface topography. So sea surface temperature changes can influence the topography, but not fully define it. That is the problem. And this SST algorithm will help for generating different fields, different plots that supports the temporal and spatial studies of ocean dynamics. So here we can see the different kinds of plots, three kinds of plots that shows SST, bathymetry, and chlorophyll A pigment for 26th September 1998 for a particular coast. The SST and chlorophyll spatial resolution is 1 kilometer. As you can see the correlation, like we can able to establish the correlation, like how the SST will influenced by bathymetry, and it will also influence the chlorophyll because we have a photic zone on any particular water body. So it can penetrate only up to a certain level. So that also influenced by the bathymetry, which shows the land surface temperature. Here comes the sea surface height. So remote sensing of sea surface height is primarily achieved by the satellite altimetry. So it is a technique of measuring the time it takes for a radar pulse to travel from a satellite to the ocean surface and get back. So that time delay will be converted as the distance from uh, the satellite and from the sea surface. So the satellite position will be fixed. That is already measured. We have the altitude of that particular satellite. So that emitting satellite signal will go and hit the ocean surface, and that particular signal will get reflected back to the same satellite's receiver. So we'll calculate the time delay between the incident ray and reflected ray, and we will convert it into a distance between the satellite and the uh, sea surface. So this can provide the precision estimation of sea level variation across the globe, enabling the scientists and researchers to monitor the ocean circulation types and climate related changes. So it actually unlike the chlorophyll, it uses the uh, active sensory measurement of sea surface height using microwave radar. So we can able to use this sea surface height in various huge number of applications and studies in ocean surface. So here is the component of basic remote sensing methodology of radar altimetry, where we can see that signal will be sent on its own and it will be reflected back to the same sensor's receiver, and the data will be established to the processing unit for further analysis. So it is the global map of seafloor topography based on altimetry. So we can able to uh, compare this particular data with the latest data, whether the sea level has been raised or lower. Obviously, it will be rising for all over the globe. And here is the comparative study of global sea level rise using altimetry data. And the next few slides will be the few applications of ocean color in remote sensing. Um, Actually, ocean color remote sensing helps us detecting various parameters. One is like coastal eutrophication from excess nutrients, like we can agriculture runoff from the land, we can say, and we can also detect the harmful algal blooms (HABs) using satellite remote sensing. Through species and toxicity may be hard to identify, especially in small or hidden blooms. Aquaculture um, finds the area with good mm, chlorophyll A levels for fish farming, and the ecosystem modeling can also be achieved. It uses the satellite data and 3D models to study the eutrophication and primary production through limited by time in small or hidden blooms. Sediment transport using satellite, that is TSM, data to model the movement and concentration that can also be achieved, and uh, phytoplankton by analyzing the light reflectance, showing different levels of chlorophyll pigmentation and water clarity changes. So this the same graph we have already seen for between the reflectance versus uh, wavelength. So here is the example of atmospheric correction, why it is very much needed in oceanographic satellite imagery. So here we can see the some scenes of satellite. So it is actually sourced from Ocean Color Monitor, that is OCM2 from OceanSat mission. The date is Jan 24, 2010. So the first image shows the top of the atmosphere, TOA, radiance of 443 nanometer. The next image shows the normalized water leaving radiance. That is also of the same nanometer. And here is the result of atmospheric correction of ocean to ocean data. And the we can see on the right hand part, it is the chlorophyll A image of that particular mentioned date. So we can see the clump of chlorophyll A concentration on the on a encircled portion. And sorry about the clarity of the image, but it shows the all different parameters of the same uh, date and same scene imagery. So it is all different kinds of band. So satellite remote sensing of ocean is like multispectral, right? So it's not just one particular nanometer or micrometer. It is of different micrometers. So that through each spectral signature, we can able to identify different type of parameter of ocean phenomena. And it is the suspended sediment map, same from OCM data of a part of India coast. So where we can see the drains of Krishna and Godavari. So we can see the river runoff, deposition of wind-blown dust, wave current, eddy current also it can be studied through this um, by using this as a part of analysis. So here it is the key satellite missions. We just quickly go through this satellite missions uh, where we will be seeing about key satellite missions that are launched from long before and till now. So first one is Coastal Zone Color Scanners. So that is launched in October 1978 by Nimbus 7, and it is designed to study the ocean color and monitor the marine phytoplankton. So we can see the band distribution from 0.00 micrometer to 12.5 micrometer, where it covers chlorophyll absorption, chlorophyll concentration, yellow pigments, aerosol absorption, surface vegetation, sea surface temperature. So chlorophyll estimation can be done by dividing the band 1 by band 2 ratio, absorption by concentration. So it must be like less than or more than 1.5 mg per meter cube. So the color coding will be blue color is for low phytoplankton and red color for high phytoplankton. So it is the general symbology of indicating the plotting the chlorophyll concentration using CZCS. Thermal data, it is not used for color composites, but it will be the information about warm or cold water zones. So we can also study the eddy and rings. Excuse me. Yeah. Um, warm core rings. It is the clockwise rotation where the chlorophyll concentration concentrates on the edge of the rotation rings. Cold core rings, it is the counterclockwise rotation where we can see phytoplankton is concentrated on the center of that rotational path. And analogous to atmospheric high load pressure systems can also be studied by Edison rings. Here comes the CSAT. CSAT is a excellent mission that we are even utilizing its imagery till now for various kinds of ocean studies and phenomenal, decoding. It is launched by USA on in 1978 for a variety of oceanographic sensors, including imaging radar, altimeters, radiometers, scatterometers. So CSAT flights tested before four instruments that uses the radar to study the Earth and its sea. The radar instrument on CSAT measures the satellite distance from the sea surface, measures the near surface ocean wind, and took picture using the radar rather than the light for illumination. So that radar technology is has been tested before launching itself, and the CSAT also carries the a visual and infrared radiometer. So it covers both pieces of spectrum. One is visible spectrum, and another one is IR spectrum. And also, by using radar, radio waves also covered, radiometers also covered, and scatterometers will cover the sea bathymetry portion, and the sea surface height also will be covered. So, various number of applications can be generated using the CSAT imageries. Here comes the CWIPS. It was launched on August 1st in 1997. So the main purpose of CWIPS is to monitor the ocean color variation, especially chlorophyll response from plankton and marine life. So the primary objective will be like plankton production only. Through that, we can study the physical, biological, processes interactions, and we can characterize estuaries and coastal ecosystems as well. So here is the spectral channels. It's all in nanometers, ranging from 412 to 865. Bandwidth is from 20, or we can have the another option of 40 nanometer. And sensor mobility, it is plus or minus 58 degree, and orbital range is from 705 kilometer. Spatial resolution is nearly 1.1 kilometer, and in GAC mode 4 kilometer. It is same as you guys have heard about the MODIS spatial resolution. It is similarly kind to this. Like we will see in the further slides about MODIS. Now, if we are able to compare the CWIPS mission with CZCS, CWebs reveals the dynamic ocean features through color and monitor. So now this slides about it's about IRS-P4. It is launched by ISRO PSLV from Sriharikota Center. It is of 720 kilometer polar sun synchronized orbit satellite mass. So the satellite mass is of 1050 kilogram. So the primary instrument is OCM, and multi-frequency scanning microwave radiometer, that is MSMR, is also been deployed in that mission. And the major focus is oceanographic application, marine ecosystem monitoring, and atmospheric ocean interaction. And this slide is about Aqua. It is launched in 2002 by NASA. It is also sun synchronized orbit. The temporal resolution is of 16-day. Temporal resolution is nothing but the revisit of that particular satellite on a particular piece of land. So that is the temporal resolution. Spatial resolution is nothing but one pixel is indicating one pixel of the satellite imagery, indicating how much of land part. So that is spatial resolution. So it is a simple definitions of spatial and temporal resolution of satellite imageries. And the main focus of Aqua is for the improve the quantification of global water cycle, and also to investigate the potential acceleration of water cycling, analyzing the interaction among land, ocean, atmosphere, and biosphere. So the sensors are MODIS, which used to imaging the land, ocean, and atmosphere, and AMSRE, that is microwave data for precision and soil moisture, sorry, precipitation and soil moisture. And we have other sensors like AMSUA, CERES, AARs, and HSB. So it is all about it is very useful for each kind of oceanographic application. And here comes the MODIS, Moderate Resolution Imaging Spectroradiometer. It is operated by LAN and launched by NASA onboard satellite. Like we have Terra and Aqua, two different satellites on this particular MODIS sensor. So these satellites are in tandem orbit so that first gathers the data in the morning and the second in the afternoon, which means the imagery is gathered at least twice a day. So that is the main objective of that. So MODIS alone takes the measurement of the ocean, atmosphere, and the land in VIS and VR, that is infrared and visual spectrum range. Marine application includes SST calculation, ocean color data acquisition at the spatial resolution of 1 kilometer is achieved by MODIS. And here we have the AVHRR, Advanced Very High Resolution Radiometer. So NOAA is the mission operated for this particular sensor. USA is the operating system, and it is also a polar orbiting uh, operational environmental satellite. It is a series of that poles, and currently AVHRR data is obtained from POES satellites, that is from 12 to 18. And this sensor uses the infrared data to provide the information about sea surface temperature. It is of very good resolution. Like we have with four different satellites, AVHRR has the temporal resolution of querying up to 16 images a day. It is very high resolution. It is called real-time monitoring of SST using AVHRR. So 2 days and 2 night images per satellite per day. So that is 16 images per day. Not only are these are the data used by marine researchers to study the ocean, but also it provides the meteorologistic key information as to directions and the strength of hurricanes still over the water. So it also reveals the uh, weather forecasting and climate monitoring studies. So here is the comparative table where we are comparing the basic spatial resolution and band channels and spectral coverage and temporal resolution of on operating system of different kinds of sensors and satellite missions. So to discuss about the major data portals where we can actually access these data to use it for further analysis of any kind of oceanographic analysis. First one is NASA Ocean Color. It is from Earth data. We can log in it for free, and we can create an account and register our name and the purpose of why we are actually registering for it. We can able to access the data from it for free. And we have Copernicus. Yes, it is the same. It is also called as Sentinel Hub commonly. So here also we can able to retrieve the huge number of oceanographic data. And third one is NOAA. So it is also like NOAA has very limited data access for free, but it is very useful. We can actually use it for many kinds of applications of oceanography. So we are at the end of session one. The session is open for any questions or queries if you have before moving on to the session two. Questions are welcome.
Hello.
Or
Can you hear me?
yes,
Okay. Then maybe if any one of you have some questions, then they can ask to the today's speaker, and maybe he will cover the technical part or the hand-on training sessions tomorrow. Today he will give the basics ideas and to get covered the things that basic that you need to do know before we start the session, right, Sharat?
Yes, yes,
So
yes, sir.
tomorrow will be more on the softwares, and today he give the basics idea, and I hope everyone understood the basics, and you can ask the questions and the doubts to him. And tomorrow he will do that in practical, and maybe if you have your laptop or maybe other systems along with you at that time, just bring it and download the software. He will tell you what to do or what to download, then you can maybe took a small practice along or after his tomorrow session. Is that okay, Sharat?
Yes, sir. Sure.
Yeah, and tomorrow there will be a small quiz session based on today's lecture, and we will provide you this PPT today night itself. Okay, so you will get tomorrow whole day to answer the question from tomorrow's today's session, and the question will be basically objective type, and it will be like a game, so it's fine. Okay, it will not going to judge whether you are getting the certificate or not. That's it. And I think there is one question by somebody. Let me read it out for you, Sharat. So, Saikat Kumar Maji, he asked, what are the potential applications of AI and machine learning in analyzing remote sensing data for shrimp aquaculture? That is his question. How we can integrate the AI and machine learning?
Yeah. So AI and ML are the the recent technologies that oceanographers and researchers are still exploring on oceanography implementation, where we can integrate the remote sensing data and train that particular model using different training data sets, and how it can be used for not just for shrimp aquaculture, for any kind of oceanographic data. So, like for shrimp aquaculture, to stick on to that this particular question, the data dependency is very much needed. So we should obviously rely on UAV or drone or even in situ data set, because the aerial coverage is very small. So we can acquire the data through drones or in situ data, and we will be uh, indicate we will be integrating that with other remote sensing data as SST, chlorophyll, etc. And uh, we will go for the accuracy assessment between the in situ data and remote sensing data. So after establishing the accuracy assessment, we will able to go through the model, like that particular model will be run, and it will be trained on the basic data sets before doing any kind of traditional methods. So it will be of basic survey. So after that we will go through a detailed survey on that particular land, and we will able to determine whether that particular landscape is uh, suitable for that culture or not. I hope it's
Okay, thank
clear.
you.
And we
Yes, I
have other
think
questions as well, I guess.
yes, there are a few more. Then I can speak the questions or take pick the questions from the chat box. That's fine. And along with that,
Yeah.
I think right now you said that the remote sensing is cover the vast area, and maybe for the small aquaculture or the shrimp farming, you can use the drone technology, right? So
Yes.
maybe in the upcoming weeks, we have a special section on the drone technology and its applications in remote sensing. That's exclusively on how we can use the drone technology for remote sensing, but not focusing on the aquaculture and all. But you will get a basic idea how the drones are integrated along with the remote sensing. And I will ask the second question, and the second question is also from Saikat, and he's also asking what are the limitations of using remote sensing for small scale shrimp farmers compared to large aquaculture clusters.
Okay.
So
So in the remote sensing, yeah, the basic limitation is the aerial cover. If it is
y-
covering the large area, obviously
mhm.
the details will be like it will be limited.
Accuracy.
The
Yes.
resolution, the high resolution data from satellite we can't expect. Only we can expect it from in situ data or drone based data acquisition. That is also remote sensing data, but still, from satellite remote sensing, we can't able to acquire the detailed data sets compared to UAVs and other techniques. That is the main limitation.
Yes, thank you, Sharath, for the answer. And during your sessions, and I think in the first couple of slides, you mentioned that we can place the sensors in different platforms. So one of those are the drones. So the drone can be used for maybe close and maybe high resolution data, isn't it?
Yes. Yeah, true.
Yes. Okay, then thank you. And another question is by Joe, and he is asking how remote sensing data can be used in assessing the mangrove covers in wetlands. Vegetation, I
Okay.
think.
So yeah, actually, the land's water, infiltration, that runoff from the land that is draining into the, ocean. That is we called as delta part. So in that delta part only we can able to see this mangrove. So this mangrove it's a big, complex, critical coastal habitat where the remote sensing will itself will confuse whether it is a land particle or ocean generated particle, or it is the either it is a mix of both. So the spectral signature is of very minute measurement. It needs high accuracies. So in mangrove identification or the mapping the mangrove cover in the land, uh, the remote sensing is very much useful for because it has the unique spectral signature other than land or ocean significantly. So it is very much useful using infrared band and visible band itself. We can able to see the chlorophyll concentration difference and the turbidity difference, the water clarity that can be seen. And correlating all these products with bathymetry and SST, we can use this, all these products for mangrove mapping, and it will be useful for others as well, like coral mapping, coral bleaching, identification, etc.
Okay, thank you, Sharath, for the answers. And the questions are coming again and again, and we will cover almost all the questions. And
Okay.
yeah, right now he said about the mangroves. We have right now a running projects on the mangroves and the blue carbon sequestrations in the coastline ecosystem, and also the coral
Mhm.
coral one, and that is based on the remote sensing. So actually, we are giving that program or giving that one to our Indians, or we have some Indian students for 1 year, 3 months, maybe 1 month, and 6 months and 9 months. Those people are doing, and if anyone of you like to do more on the carbon sequestrations or the assessment of the mangroves or coral bleaching related to remote sensing or maybe the ground field works, please contact us again. Okay, so another question is from Raghavi Sri T, and he's asking, or he or she is asking, how to estimate this chlorophyll or chlorophyll A, I believe, values from satellite images.
Yeah. Raghavi Sri, she's actually got into the main nerve of the PPT. Like, yeah, to estimate the chlorophyll value from satellite images, we have specific unique bands. As I already mentioned in the slides, there are different spectrum of electromagnetic waves that can be accessed from satellite to the Earth's feature. So in that each unique bands have unique values that indicates which particular matter or the particular thing that is exist on the Earth. So chlorophyll A, B pigments have distinguished spectral signature where it will be a direct reflectance from the earth that is captured on the satellite, and it will be recorded as acquisition will be recorded as digital numbers, and that each pixel number value will be printed as digitally printed as a satellite imagery. So that is the view that we are getting from the satellite of that particular ocean. So chlorophyll A is the particular band of any kind of satellite missions we can take. For example, mode is aqua. So aqua, chlorophyll A is the main hero of that satellite imagery session, where we can see the different kinds of chlorophyll A, chlorophyll B, and other suspended particles. Other different parameters also are covered in that particular satellite mission. So chlorophyll A is a particular band on a particular sensor where we can take as it is and we can establish a plot over it. So that's it. So chlorophyll is a proxy of phytoplankton, as already said. So it is also the I can cover the answer for next question as well. So how the fisheries can be the fish potential zones can be identified through remote sensing. So chlorophyll is a proxy data for phytoplankton. So along with it, remote sensing reflectance of different nanometers can be used as a proxy for different parameters like turbidity, suspended sediments, and along with it, we can use the SST as well. So I have an excellent case study in the session 2 where we can see the proper methodology of how this, chlorophyll A, SST, and turbidity is used to identify the fish potential zone of any area. So we will see detail in session 2.
Okay, then you answer that questions as well. And next one is by Shine. And here or his question is: does the does the SPM or CDOM interfere in pigments analysis? Do they interfere?
Does the SPM's CDOM interfere pigment analysis?
Yes.
Uh, can you able to understand the question? I can't. How
Actually,
how does
we
the
have. Okay. Maybe she can again text it again there, or
yeah.
the my understanding is that how we will differentiate those two
Hmm.
whenever we analyze the spectrum.
Acha, okay. So yeah, SPM and CDOM, these are the two uh, uh, reflectance signal where it indicates the turbidity. And pigment analysis, maybe she meant chlorophyll pigments. So yes, of course, these two are go hand in hand. It is actually the answer of this question is chlorophyll versus turbidity, whether it will coexist or whether it is inversely proportional. So my UG major project was the same, whether the chlorophyll and turbidity will coexist. If that coexists, what are the scientific or oceanographic phenomena that interferes in that particular coast or bay? So to answer this in detail, of course, there is some interaction between these two parameters that involves so much of scientific and oceanographic science based concepts. I guess I'll just quickly go through if time permits. I'll quickly go through the my my study. Like I'll show that PPT as well to you, so that you can have the clear idea about whether these two parameters have this correlation or not. Next question.
Next question is again by the Joe, and he is asking about the mangrove systems is present in traditional filtration systems of shrimp farming, and this coverage data is needed for international sustainable aquaculture certifications, where he can
Mhm.
get that particular data, and is there any reference for the mangrove data and all?
For mangrove and underwater seagrass. So these are all the recent research I have seen. Like many oceanographers and researchers are into now. So I'll refer this data sources for mangroves and about the shrimp aquaculture. I'll just refer and let you know in the further session by tomorrow. Is that fine?
Yes, I think he will join tomorrow as well. Then you can answer the questions tomorrow. Maybe you can give the answer. And Saikat is asking again a questions. What
Mm.
spectral indices are most reliable for differentiating dissolved organic matter was suspended solids in turbid coastal aquaculture zone? And he have a follow-up questions as well. Maybe you can cover that one first.
What are the spectral indicators are mostly reliable for differentiating? Uh, okay. Okay. How can UAV drones, multispectral imagery can be calibrated to detect the subtle bio-optical changes associated with stream stress or pond bottom deterioration? Okay. So UAV doesn't actually, so the sensors that we are deploying, any sensors that needs calibration, but the sensors that we are deploying in the drones will not be much difficult as we are the techniques that we are using for satellite remote sensing. So I don't know actually. These guys are very interested in shrimp aquaculture and mangrove. That I don't have much knowledge about that particular thing. I'll note all these questions and I will refer it and I will let you know by tomorrow session. So I think by this I'll make these guys to attend tomorrow session as
Yeah.
well.
Yeah, yeah. Actually, they all will join tomorrow sessions as well, I believe. And actually, I have one question. Maybe you were mentioning about the calibrations of the data or the sensors, right? So, how
Hmm.
can we actually do that calibration? Do we need to do that while we install in the sensors, or after we get the data, we
Yes.
have to calibrate the data?
Okay, so before deploying it, actually, the flying platforms. So UAV is a platform, and the sensor is the the device that we are deploying in that platform. So sensor has to before deploying it in the platform, the sensor has to be initially calibrated. The primary round of survey has to be done just by holding it on hand or placing it on a static place, and we will gather the data and we'll just go for the preliminary round of atmospheric and geometry corrections. So whether it is if it is giving a proper channel of series of images in a correct order of nadir points. We used to call it as nadir points, where the proper overlapping of such a succession of consecutive images. So if that can be achieved, then it can be deployed in the sensor, and it will go through again a round of calibration and pre-processing, and then it after the proper accuracy assessment of pre-processing, we'll get into the analysis and post-processing. The proper preliminary survey is very much important for any kind of sensor before deploying into any kind of platforms.
Okay, thank you so much, Sharath, for the answers. And I have maybe one more question, and that is basically
Yeah.
on one of the graph that you have shown here, and you were comparing
Mm,
and correlating the temperature and the depth, the
mm,
bathymetry, and one more. And can you just go to that
mm.
slide once again,
Yeah.
if you don't mind?
You mean the plot or the graph?
Yes, three plots.
Yeah, yeah, yeah.
Maybe
I,
at the beginning, I think. Just at the
yeah.
beginning.
I
Yeah,
think
that one.
I think it's
Yes, yes, this one.
mm,
And in the sea surface temperature, maybe I
mm,
think we can see here on the the temperature higher temperature is the red one, and also in the
yeah.
top area there is a brackish water or maybe the estuary, and the estuarine temperature
Mm,
is also high, just like our maybe after the economical zone. So why that is? Is that too red there, right? That's too red, right? That one.
So,
That is also very high
on
temperature.
yeah, in chlorophyll, right?
Because
In chlorophyll A pigment, right?
yeah, yes, yes. And actually the first one,
Okay,
the season first temperature, SST, 26 September
okay.
1998.
Hmm.
We can see a
Hmm.
higher temperatures in the estuary, and also we can see the higher far away from the coastline, but not within this area. But is that
Okay, so
do you know why that
yeah,
is?
yeah, yeah. Yes, yes. This is because of the runoff, land runoff. So the land runoff will actually get the turbid water, which is very rich with nutrients and sediments, which will have other particles as well. So it is actually the temperature that it is the running water, the temperature of the running water may be that cool. And towards when you go towards the sea, the top it is just the sea surface temperature, right? It's not the on the all through the ocean column. The water column will have different kinds of temperature on at different depths. It's just about
Yes.
the surface temperature. So the
Mhm.
sun's influence, even the bathymetry is very low on the coast part. I mean, which is nearer to the land, but the influence of the land runoff or agriculture runoff, or we can say the field runoff, the water with carries so much of sediments that will cool down the water, and the interact that velocity of that water will also will get the turbulence and creates and it will reduce the temperature. It is also one of the case, but I don't know what particular case happened in here, because as you know, oceanography is very much difficult to determine whether this phenomena is responsible for this. So we need to analyze every single parameter to actually conclude the answer.
Answer, yeah, yeah. Okay, got you. Because I also surprised, like in the coastline, maybe it is maybe
Hmm.
very cold because of the
Yeah, yeah,
maybe input or inflow. But in the
yeah.
estuary, it is more red than the coastline. That's why I asked. Anyway, we want to include everybody's questions and all into it, and our sessions normally like that. So I will just call the names to know how they understood the topic, and also do they have any questions. Okay, so the first one is Abhirami T. Abhirami, are you there? Abhirami, is everything all right? You can text, or
Yes,
maybe you
sir.
can open. Yes, Abhirami.
Yes, sir.
Okay, do you have any questions for today's session?
Yes, sir.
Okay, everything is clear, right?
Yes, sir.
Yes, okay. And uh, Agalya Balan. Agalya. So maybe you can text in the chat box, or you can just speak. Maybe Arundhati. Is everything good? Arundhati, are you there? And uh, Divya. Hello, Divya. Okay. Divya.
Sir,
Yes, Divya.
everything is fine, sir.
Oh, okay. Okay, you understand that, right? Understand the
Yes, sir.
concepts and all.
Yes,
Okay, so
sir.
if you have any questions, then you can ask to Mr. Sharath. Okay, today's
Okay.
lecturer. Then Dr. Gulnas Qureshi. Doctor? Hello, doctor. Are you there? Okay, thank you. And Mr. Joe, he already asked a lot of questions, so it's fine. And Jyoti? Hello, Jyoti. Yeah, thank you. And Jyoti Upadhyay. Are you there, Jyoti? Bavuleshwara Rao, are you there? Hello, Navya?
Yes, sir.
Okay, you got the points, right? Do you have any
Yes, sir.
questions? Do you have any questions?
No, sir.
You can
No, sir.
freely interact with the speaker. Okay, everyone can freely interact with the speaker. Then only you can gain more knowledge. Okay, so you don't need to afraid anything like nothing about the language. You can speak it in Hindi or Tamil. Then we can translate that for the speaker if you don't, but he can understand both of them. Okay, so
I
Navya,
can understand Malayalam as well. Any kind of
yeah,
South Indian language.
yes. So
Yes,
Malayalam,
I
Tamil. Yeah, do you have any question? Who? Navya, right? Who is that?
no everything. No, yeah, everything was fine.
Navya. A name, please.
Okay. Navya,
Okay, Navya. Thank you.
thank you.
So then we have the Rahavasri T. Rahavasri. She asked the question. Then I believe
Yeah, yeah,
she's
she asked. She asked questions.
yes. She asked the questions. Very good. So do you have any other questions, Rahavasri?
Sir, it would be more helpful if he could show us how to like estimate the values from the satellite data, so
Oh,
we
oh,
could easily keep up.
yes. Okay. Like this, you can give him some suggestions. So tomorrow we
Yes.
can add that one also, right, Sharath?
Suggestions are very much welcome because the session is all for you guys. The,
Yes.
be- the, be- the the benefit party has to be you guys. So the suggestions are most welcome. Any kind of suggestion like this are most welcome. You can also put it on the chat box. And
Chat
about
box.
Rahul Sri's suggestion, I will accumulate as much as hands-on thing, and I will go get about how the values can be extracted, and it can be mapped spatially and temporally in next session, tomorrow's
Yeah.
session.
Thank you, sir.
So I hope we can cover some of the parts, and maybe in the future we will conduct again another one.
Yeah, yeah.
Okay, if we don't cover everything, we can conduct again. So shine and shine, shiny. Sorry, shiny, shiny. Okay, shiny. Thank you. Then Samyukta, Samyukta, right?
So, yes, sir.
Hello.
Sir, tomorrow's class, can you tell while telling Andrew Seagrass details also?
Yeah.
Can you speak again?
Okay.
Oh, okay. You already
I
listened
she
before,
wants
right?
me to yeah, she
Uh,
wants me to add points on seagrass. Seagrass,
uh, okay.
shrimp aquaculture, and mangroves. So I will
Uh,
get all the concept done by tomorrow. Don't worry.
oh, yeah.
Thank you,
Okay.
sir.
Very good. So thank you. So we can add and learn something more that is closely related to your current research or your interest. And Varun, hello.
Yes, sir.
Yeah. Is everything clear for you?
Yes, sir. I have understood him.
Oh, okay. So, do you have any doubts or do you have any suggestions or do you have to tell him that I want the particular thing? Anything?
Nothing, sir. Everything's fine.
Okay. So, I hope today's sessions was very useful for each and every one of you. And we will try to incorporate everything that is possible because as you know we have few limited time for the sessions, but we will try our level best to add maximum thing to it, and Sharath will cover the answers that he was unable to answer today. And we also have some time bonds, so we have to wind up our today's sessions. Okay. And yes, if any one of you need any other further sessions, we will do that continuously for the fishery sessions and focusing only on the mangroves and only on the seagrass, how to do that. We will do that in the future. And this is our starting. So you don't need to much worry about it. And thank you so much. And Sharad, maybe you can wind up the sessions by a small note on today's
Yeah,
session.
actually, yeah, I was planning to give it as a two parts. First one is the major that I have covered. Second part is like it covers all the SST and chlorophyll, and we have PFS advisories, that is general norms for fishing activities, and algal blooms and coastal water monitoring, and tuna fishes case studies. That is all. I think it will barely take 10 minutes, 10 more minutes. Will that be okay to I can take now, or hello? Hello?
Hello, sorry. Actually, earlier we had 21 people, and after the end of the sessions, few of them left after they asked the questions and all. So, if we add something more today, then they will miss it. Okay.
Okay.
So, we will do that tomorrow. Is that okay?
Fine. Okay. Fine, fine, fine.
Yeah. Oh, okay. Thank you.
Uh,
Then thank you. Yeah. Anything?
uh, like all the questions that you asked, which has been unanswered by today's session, will be cleared by tomorrow. And tomorrow will be more of practicals and hands-on session, where I planned to cover the basic acquisition of data, how to access, and how to interpret and visualize what is the value, and how can we really relate on the real world. So these are all the basic agenda of tomorrow's session. So stay tuned, and as sir said, we'll be having a small uh, quiz segment as well for tomorrow, after tomorrow's session. So I hope you all really enjoy by today's session, and good night, everybody.
Yeah. Okay, thank you so much, Sharad, for giving such a insightful session to our students. And maybe tomorrow you will continue the sessions, and they can gain more knowledge about the remote sensing. And we will continue this series, the remote sensing series, because we are getting a lot of questions and inquiries regarding the remote sensing courses. So, yeah, good night for today, and we will meet again tomorrow on the same time. And good night. Right.